Okay, chemical reaction and energy part 2. It describes the simple colorimetric method. It refers to the method for determination of maybe delta HC, maybe delta HN, delta H solution, and delta HF. Okay, all of this value, okay, are determined experimentally, okay, in the lab. Okay, now number one, we have this example, okay, determination of enthalpy change of combustion of ethanol, okay, which is very commonly to be represented by the symbol delta HC log ethanol, okay, bracket. State must be present. Okay, normally the experiment will be conducted in colorimeter. Okay, it is device, maybe glassware, to isolate the energy exchange between the reactant system and the surrounding environment. Okay, perhaps the Wickham fast might be better, but due to the limitations of our maybe glassware or equipment, beaker with some cotton wool, okay, sometimes it is also acceptable, okay, but perhaps Wickham fast might be better. Back to here, colorimeter to determine the enthalpy change of combustion of ethanol. Sometimes in the exam, they might have the flammable liquid like methanol. Okay. Now, when we refer to the equation, okay, energy, heat given out, okay, is equal to mc delta T. The heat given out sometimes will be represented by the symbol Q or E. Q is quite commonly appeared in your textbook, but both of them the symbol are acceptable in DSC. Now, you can able to see delta T, right? So you need to obtain the data of delta T. Where you can get it, okay? Measure the temperature change, okay, before and after experiment. So you have two data, okay, T1, T2, right? Let's say T1, 41 degrees Celsius, T2, 83. So you can able to calculate the delta T, right? Then how about M here? M refers to the mass of water you used it. Now, however, you have only the data, okay, 100 cm cube, okay, 100 cm cube water, 50 cm cube of ethanol, let's say. So what is the mass of water? How to get it? Now, because we knew that the mass of water, okay, can be obtained from its density. The density of water is 1 gram per cm cube, understood? Okay, it is understood. Okay, so by cancel out the unit, okay, so 100 cm cube, we have 100 gram of water. Okay, can you get it? Now, but for other liquid, the density is not equal to 1 gram per cm cube, but because of the convenient, okay, or limitation of data, so for more convenient practice, we will assume maybe ethanol, the density of ethanol is the same as that of water. Okay, this is one of the assumptions. Okay, perhaps they may ask you any assumption you can make in the experiment. Okay, 1 mark for this. Okay, now no panic. Okay, the assumption you may able to find in the next few pages later. And okay, what data you can take it? After the experiment, you should take it. Mass of water here. Okay, easy, right? Temperature change, delta T, and the mass of ethanol to be burned. Now, after you get the energy released, how to get the enthalpy change? Now, QE refers to heat change, refer to heat only, the energy given out only, the enthalpy given out only. It is not equal to the heat change. It is not equal to the enthalpy change. Now, if The question asking you for enthalpy change, you need to divide it by number of mole. Do you remember in the part 1, we already discussed it. The delta H, the unit is kilojoule per mole, right? QE, you calculated here, the unit is kilojoule only. Okay, so you need to divide it by mole. Okay, which species mole? Definitely the ethanol, okay, number of moles. Okay, perhaps the data here, okay, is not sufficient to get the number of moles of ethanol, but you should know it. Bottom, you should divide by number of moles of ethanol, but not anything else. Okay, kilojoule per mole. Now, this table, okay, is written down to remind the candidates. Okay, don't use the wrong unit. Because this is the very first time you encounter, okay, C. A C is the specific heat capacity. Specific heat capacity, okay? It refers to the amount of heat absorbed by that substance, okay, per gram. Now, sometimes they will give you 4.2 joule gram to the power -1 K to the -1, okay? Now, then the mass multiply C together, you can use 400 gram. But sometimes if the specific capacity given is in terms of kilogram to the power -1 kilogram, okay, then the mass you used it here, you need to convert to kg, okay, gram converted to kg, or vice versa. Okay, so you need to be a little bit smart towards the unit given here. You will understand more after we try the typical question in the next pages. Now, as I mentioned before, they are important. So, I don't mind you memorize the method in calculating this kind of questions. Okay. Right here, you will have calorimeter, some sort of data. Let's look at the question first. Write down the chemical equation for the combustion of ethanol. Perhaps don't worry for the answer. Okay, I assume all of you can able to get it well done. Second, heat energy absorbed. Now, don't get wrong with the question they are going to ask. Heat energy absorbed. That means they're asking for Q or E. Enthalpy change, they are asking for delta H. Okay? So, if they're asking for Q, okay, what you need to do, okay, what you should use for the formula, obviously Q equal to Q equal to MC delta T. But for this case, more than one substance. Yes, more than one substance. Okay. Now let's take a look. Now we will have the formula M C delta T. Now, if more than one substance, we will use M1 C1 delta T plus M2 C2 delta T. Okay, delta T must be the same. Okay, for the temperature change for these two stuff. Okay, number one, we have 50 gram. Okay, what is the one correspond to? Refers to the water. Okay, mass of water 50 gram. C is this time we are lucky. The unit are coherent, okay, gram to the power -1, okay, gram, okay, if they give you kg to the power -1, you need to convert gram to kg, otherwise the total value you calculated is wrong for part B, part C, part D, etc. Okay? Temperature change, okay, just the difference. And how about 380? What's 380? Okay, now, sometimes if the specific capacity, okay, is given for the copper calorimeter. Okay, because not only water will absorb energy, metal will also absorb energy. Actually, all substance will absorb energy. Okay, if the data is provided, you must include in the heat, included in the Q. Okay, now they given out copper calorimeter. Okay, the specific capacity is this value, and then multiplied by the mass of mass. Okay, and the temperature change must be the same. Okay, because we consider this is the whole calorimeter. Okay, and then unit kilojoule. Okay, unit kilojoule. You can predict they will not only ask you heat released, but enthalpy change. Before you evaluate the enthalpy change, you need to get the number of moles, right? Number of moles of what? Of course, ethanol. Okay, how to get the number of moles? Mole equal to mass divided by molar mass. Ethanol, where is the mass? Where's the mass? Okay. Oh, right here. I already highlighted here. Okay. Before and after combustions, okay, difference will be the mass of ethanol, okay, being burned. Okay, that means right here. Okay, molar mass. Okay, understood? And then you can get the mole. Okay, now in the exam, honestly, they will ask you for part A and part D directly. That means they will not have part B and part C. Okay, this is demonstration question, so it will go into detail. But in the exam, they will only ask you part A and part D. Part A maybe 1 mark, part D maybe 2 marks something. Okay, and then we will have further questions asking about this experiment. Maybe they ask you stage 1 assumption, okay, in the experiment, etc. Okay. So WHC not part B answer divided by part C number of moles. Okay, that's it. Okay, and the unit will be kilojoule per mole. Okay, kilojoule per mole. Okay, right here. Kilojoule per mole. Okay, that's it. Okay. Recall what I say for the assumption. Okay, is right here. Okay. 1 mark maximum. Okay. Perhaps maybe you memorize maximum 2 is already enough. Okay. Heat loss to the surrounding. Okay. Heat loss to the surrounding. Okay. This is one of the possible error. Okay. And the specific heat capacity of the calorimeter and the thermometer, okay, was not taken into account. You can able to see the thermometer will absorb heat, right? But we didn't have its specific heat capacity. Okay, so it is negated. Right? Perhaps incomplete combustion may occur, and the experiment was not done in standard condition. Perhaps if I were you, I will write down the last one, okay, and the first one, most straightforward, okay, because if we conduct the experiment, obviously not necessary under 25 degrees Celsius, 1 atm, especially the temperature, right? Maybe right now the temperature today is maybe 21 something, okay. Okay, second, okay, this is also very important, 100 star. Okay, delta HN naught. Okay, what stuff we need to prepare? Vacuum flask. Okay, it is a insulated calorimeter. Okay, now we have two choices. For the determination of enthalpy change of neutralization. Of course, left-hand side will be the best, but due to the limitations of our equipment in the lab, right-hand side, this setup is also okay. And furthermore, we will have bowl, okay, expand the polystyrene cup to prevent the loss of energy from the reactant system to the surrounding. Yep. Okay. Provide extra insulation. Okay. Details is just like this. Perhaps the calculation comes more important. Okay. Now because neutralization, water will be formed, right? Okay, acid plus alkali to form salt and water. So, I didn't highlight this, emphasize. For envelope change of combustion, it is a negative value. It is a mass. And how about neutralization? Negative value is a mass also. Okay, so so MC delta divided by mole of water. Okay, that's it. Okay, and we assume the density of acid and alkali to be the same as that of water. That is 1 gram per cm cube. Okay, because we don't have enough data, okay, for the experiment. Okay, of course, if they have, okay, you multiply with the density of acid and alkali, but mostly they will not provide. And sometimes what I said before, sometimes there is 1 mark for the experiment. Okay, for the DSC exam. Okay, and so after the reaction, the total mass of the reaction mixture will be 100 gram. And the heat released at MC delta, right? Okay, M 100 gram, okay, C provided here, okay, and then check, okay, the unit, okay, together are coherent, okay, yes, and then you can multiply them together, and then plus times delta T, okay, you get the Q, okay. And this point, okay, is most quite a number of candidates may have error here. Listen very carefully. Ignore what I write down here. Just read your notes letter paragraph. For this experiment, because the number of moles of hydrochloric acid and the high sodium hydroxide is the same, and very lucky, the mole ratio between them are 1:1. So you are not required to assess to make decision which reactant is limited or which one is assessed. But in the DSC, there will be question asking you which one is limited. We will only use the number of moles of limiting reagents to determine the number of moles of water. Okay, so don't make yourself get it wrong. I give you another interpretations. If they are the same, no one get problem, right? But if I assume if the number of mole of sodium hydroxide is limited 0.04 mole, so 0.04 mole of sodium hydroxide will only react with 0.04 mole of hydrochloric acid. So obviously, which one is limited? Sodium hydroxide. So we can only use this value 0.04 to get the number of moles of water, but not 0.05. Can you get what I mean? If you just put up random, okay, 50% of chance, okay, you get wrong. And the afterwards part C, part D question all go wrong, okay? So if you can make clear about the limiting reagent is okay for this part, okay? And then divided by, for this case, divided by 0.05, negative is a mass, because in the part 1, you already memorized delta Hn, no, it must be negative. So you will get negative 50.4 kilojoule per mole, but in your mindset, the theoretical value is 54 point something negative value. Okay, why? Okay, there is a discrepancy between the experimental value and the theoretical value. Okay, just check this out. Okay, so perhaps you need to memorize 1 or 2 points. Okay, I just let you know 2 points are very straightforward. Even primary student, okay, they already knew about it. Okay, number 1, no matter how accurate, precise, reckon fast you get used to the experiment, heat loss still, okay, to the surrounding, right? And second, do you think the experiment is carried out under standard condition? No. Okay, so these 2 points, okay, number 1 and last, okay, will be enough. Okay, but perhaps some of you, okay, want to gain an insight into the errors, what happening. Number 1, 2 items, okay, the specific capacity are not taken into account. Okay, thermometer, the expanded polystyrene cup. Second, we just assume the specific capacity of the reaction mixture is the same as water, but actually they are not the same. Density is same as water, okay, which is actually not. And incomplete reaction might occur, but this is quite rare because neutralization often complete, except for with acid or with alkali involved. Okay, practice made perfect. Okay, next page. Now, usually in the DSE, they will give you a graph. I cannot say usually, maybe often. Without the straight line, green straight line here. You may only find some sort of experimental data, okay, in dot, something like this. Then how you can determine the delta T? Now, precise, accurate determination is important for your data manipulation because you need to use the delta T for further manipulation of the delta H, right? So if you got the wrong T2, now T1, kindergarten student, okay, can get it. But T2, you may have variation from maybe Sia or Sarha, okay? Maybe Sia, okay, she got maybe 31 here, okay? Sarha, okay, got 43. Then which data is correct? You need to have proper extrapolation. Now, you can make the dot, maybe some of the dot are out of the range, okay? Of course, you can make the line like this, but you make the straight line, okay, to let all the dot passing through, okay, the straight line like this. This is the proper extrapolation, okay? So you got the data here, okay? But if Sia, okay, have the extrapolation like this, okay, of course the data go wrong, okay? Next, enthalpy change of solution, okay, sorry, only 2 experimental determination are important. Number 1, delta HC naught and delta HN naught. These 2 are not important. These 2 are not important, okay? Don't waste time on them, okay? They will not be asked in DSE. Never asked it. But of course, if you ask me, okay, how to determine, okay, of course by simple calorimetry method, and we have the similar formula, MC delta T, and develop a mode of solute. Solute refers to the solid and a compound dissolved in infinite amount of water, okay? If you forgot, you refer to the definitions in the part 1. can be either negative or positive. Okay, and okay, let's take a look on the example. Okay, and they say 5 grams of pure ammonium nitrate. Okay, dissolved in 62.5 cm cube. Okay, you make adjustment. Okay, for your notes. Temperature raise. Okay, you can get the delta T. And what assumption you can make? Sometimes you will got 1 mark. Okay, assume the heat capacity and the density of the solution are the same as that of water. Okay, and okay, how to get the delta H? Okay, now because this experiment is cannot tell. It is whether it is carried out under standard condition, so I didn't put the not here. Okay. Not on or forgot to write down not is not important. Important is the data. Okay, 1 mark for the formula, 1 mark for the final answer, together with the correct unit. Now, because we assume, because the mass of water, okay, 62.5, okay, because we assume, how to get 62.5 gram? Because we knew that the density of water is 1 gram per cm cube, right? And 4.2, okay, is where is it? Okay, we assume they are the same. Okay, so 4.2. Are the two data, the unit match together? Yes, gram to the power -1. Okay, and temperature change, mass over molar mass. Okay, the molar mass of NH4NO3, I assume you're able to get it. And then the value is 24.78. Okay, but if you just write down 24.78, sorry, in the exam, no mark. You must specify whether the value is positive or negative, even the figure is positive. Okay, and the free radical value is should absorb more heat. Okay, why? There's a discrepancy. Okay, so you refer to the possible error. Okay, heat loss to surrounding, the experiment is not carried out under standard condition, blah blah blah. Okay, very easy, right? Okay, pause for 5 minutes. Okay, try the classwork in the next page. For the classwork, okay, how to get it well done? Okay, now of course we use the same solution, right? Same solution. Let me see. Now, I didn't remind you in the example. Now, when the temperature change is dropping, so heat is absorbed. But when the temperature is increasing, so heat is given out. Okay, so maybe you may ask me, well, sir, for delta H solution, okay, how can I predict is it negative or positive? I'm confused. That okay, dropping down in positive, in temperature raise negative. Okay, very common. Temperature raise, that means heat is released, right? Okay, and let me see. So, steam of hydrogen chloride was bubbled into 50 cm cube of water with a flow rate of 10 gram per minute after 10 seconds. Temperature raise like this. Now, perhaps you need to convert. The unit to gram per second. Okay, like 10 gram, 1 minute, 10 gram, 60 seconds, and then you will got 0.1667 gram per second. Okay, so after 10 seconds, okay, every second 0.1667 gram of HCl will be passing through. After 10 seconds, how many gram of HCl passing through times 10? How about 20 seconds times 20? How about 1 minute times 60? Okay, that's it. Okay, so here is obtained from there. Okay, mass divided by molar mass, mole. And then on the top will be the mass of water, 4.2. Make sure the units are coherent. You should know what I mean, right? Times temperature change. Okay, so finally you will got negative 17.8. Okay, now what I write down here is wrong. Okay, I just demonstrate some wrong example of some candidates. Okay, and why might be the result more reliable if the volume of water was increased? Because based on definition of evaporation of solution, we need to dissolve the, let's say, ionic compound in indefinite amount of water, right? So we need to make sure the solution is carried out at infinite dilution, okay, to until no further heat change can be detected. Okay, you can refer to the definition. Okay. Last part for part 2. Determination of enthalpy change of formation. Now, this part will not ask that in exam. They will only ask you in ARQ in MC question or some part D, part E question, only 1 or 2 marks. Number 1, you need to aware that delta HF cannot determine, okay, experimentally. Why? Why we cannot determine it by simple calorimeter? Why? Now, number 1, you need to able to write down the equation for the formation first. For this one, when you able to see the symbol here, you should able to write down the equation corresponding to. Okay. Now maybe you will say that carbon react with oxygen, okay, at high temperature to give CO2. We can measure the heat given out, okay, when we burn carbon in the simple calorimeter, etc. Blah blah blah. But there are some side reaction actually happening. We cannot control carbon must react with oxygen to form CO2. It can form CO, right? It can form carbon soot, right? Okay, if the reactant is a very long chain hydrocarbon, okay, so the reaction is uncontrolled. Okay, due to the side product formed. Okay, now this very the reactant is very small. Let's consider, okay, delta HF, sodium hydrogen carbonate. Okay, pause for 1 minute to write down the equation responsible for the formation of sodium hydrogen carbonate. Do it now. Number 1, you need to write down the reactants, okay, involved. That must be in their standard state. Sodium, solid, hydrogen, H2, oxygen, O2. Okay. Now, because based on the formula, 1 mole of sodium hydrocarbonate must be formed. Okay, so okay, you write down some fraction here. Fraction is acceptable. Okay. Why? Suggest one reason why we cannot determine the delta HF. NaHCO3 solid in the lab. Due to the side reaction to give maybe sodium carbonate, maybe CO, maybe CO2. Okay, reasonable. Okay. maybe water. Okay, and okay, pause for 1 minute. Okay, write down the equation responsible for this. Okay, now you should able to write down the magnesium at the physical state, sulfur at the physical state, oxygen at the physical state, 1 mole of magnesium sulfate. Okay, 1 mole also. Why we cannot determine in the lab? Due to the side reaction to give maybe SO2, maybe MgO, okay, etc. Okay, that's it for part 2. Okay.